Good evening all. So this is the recorded video. As we will go online tomorrow, I will try to conduct an online class. So as for now, we will discuss about the slope stability or stability of slope. So earth retaining structure I have discussed in class. I think last graphical solution is left. You can understand many NPTEL videos are available. Just go through the videos. I have asked many times. If you have any queries, please let me know. No one has sent any message or any doubt. No one has solved any examples, nothing, and simply are saying that madam has not given any notes, madam give me notes, all those things. It's okay, we'll just discuss the slope stability and CI portion. For the A division, you will be having stresses in soil and as well as this one wait a second, lateral earth pressure and slope stability up to today's class. And B division, you will be having half portion of the stresses in soil, earth retaining structures and slope stability. These three chapters are for your second CIE. So slope stability we will discuss today and some of the portion we will discuss tomorrow. So first we will start from the slope stability. So why we have to study the slope stability means, so what exactly slopes are? Many slopes we have. Slopes are nothing but it's just a inclined surface, inclined surface. Okay, this is normal, this is the slope. And where you see these things, this may be it may be man-made or natural sources, man-made or natural. So man-made, just like embankments for highways, railroads, earthen dams, temporary excavation, tips and spoils heaps, landscaping, all these things are man-made slopes. And you can see the same thing for the natural also, natural slopes, landscapes you can see. And these things must be in stable, or they must be under equilibrium, or else the whole structure is going to be collapsed, the whole thing. If this is not unstable, if slope fails like this, that means obviously whatever, if this is the road and here this much of the soil fails, means obviously it will cause some damage or losses. So for that it must be unstable. For any slope to be stable, what you have to first think is what are the forces coming on the slope. Based on that you have to design the slope. Designing slope is nothing but the giving this angle. So whatever the angle you are giving, theta it may be or alpha it may be. So designing the slope is nothing but the angle and this span. This is what the designing of the slope. Very simple chapter. We have 2 to 3 methods to design the slope. In everything what you are going for this inclination, you are determining this inclination. That's what we call it as a designing. So before going for this, we should know some basic things, that why slope is going to fail. When you call slope as failed, or when you say that slope is stable, all those and types of the slope failure and types of the slopes, what types of the slopes you have, and what is how the slope is going to fail, and what are the causes or forces coming on the slope. So what exactly failure means? When forces, when total slope collapsed or move from high point to low point, that we will call it as failure. So what forces our main forces are seepage forces and gravity forces. So these are the main forces which will cause the failure. Okay, so the most important of forces which cause instability are the forces of gravity and the seepage. So I also made a list of slope failures: gravity, seepage, earthquake, erosion, geological features, construction activities. Gravity forces, as you all know, because of the gravity there will be, so because of gravity there may be chance of falling the slope, that is the because of the gravity force failure occurs, that is one of the cause. And second one, seepage failure, because of the seepage water obviously soil loses its strength and failure may happen. Earthquake, which will continuous shaking, will cause the failure. Erosion, so this downstream, this we will call it as so anyone, if you are something is holding here, that may be the downstream, so this downstream may got eroded, so that will be the because of the erosion. And next one will be the geological features. So geological features means if the strata of the soil, here one soil, here one soil, so whatever the joints the soil may get failed, that is the geological feature. Construction activities, so any side, this side construction, this side construction, and you have excavated the soil from this side and from this side, again it will disturb the slope and it will cause the failure. These are the causes of the slope failure. So these are what the you can call the forces coming on the slope, or what are the causes of the slope failure. Why we have to study these things means, when you are designing the slopes, we have to remember all these forces are acting or coming on the slope. So we should design our slope so that it should resist all these forces. What exactly, how exactly? If gravity force is more than the resistance of this soil, slope is going to fail. Same thing here. So whatever the stress developed because of these forces, if that stress is more than the strength of the slope soil, then slope is going to fail, or else it is an stable condition. So when slope fails, when all the stress developed because of the for these forces is more than the strength or resistance of this soil, then slope is going to fail. So you have to design such that whatever the resistance, shear resistance or shear strength of the slope must be greater than all these forces. So for designing this, we have some of the methods. So we have many methods, among that only 3 or 4 methods you have for your syllabus. On each method, if you study thoroughly, direct question will come. Just explain the slope stability on this particular method, explain the slope stability on this particular method, like the direct question you will get, and direct problems also you will get, that some of the graphical solutions you will get in the exam. So very easy chapter, try to be prepared, and it is helpful further also. So now again, why slope is going to fail? These two are little bit same things. So obviously why it is going to fail? Because of the soil type, next soil structure, and because of the ground water, and because of the seepage and slope geometry, the shape of the slope you can call. So these are the conditions why your slope is going to slope failure completely depends on these factors. Obviously these are common, or you can say everyone know that soil types plays an important role in case of the stability. Soil structure also affect, ground so affect, and seepage also affect. So now we will see what are the types of the slope failure. We got that because causes for the slope failure. Now slope failure depends on now how the slope is going to fail. Okay, before this one already we have discussed in the earth retaining structure. I'll just remind the things. So we have drawn a wedge like this, and this we have mentioned as a failure envelope or failure plane. I have also told this thing that while explaining, the failure envelope is never in a straight line. It will always fails in a curvical form, a circular form. So whenever you will see a circular form, that is the failure plane or failure envelope. Failure is never going to, sorry, sorry for that. So failure plane will never be straight line, but forever we have assumed and drawn this in case of the earth retaining structure. So here everywhere we will draw it as it is in a curvical form. So I have already some diagrams we have, so that for that diagram I have told. So first, normally types of the slope failure. So types of the slope failure we have lots of failures here. Before that we will go for the types of the slope. Sorry, that I would have told first only. So types of the slopes. What types of slope? Already we have discussed. We may have man-made slope, and another one is natural slopes. Obviously name itself indicates man-made slopes are just like we have discussed, embankment of the roads, highways, railways, earthen dams, temporary excavation, tips and spoil heaps. All these things are man-made, and we have landscapes. All those things are natural slopes. And again another types is infinite slopes and finite slopes. So infinite and finite slope. Normally infinite slope we call it as it is available naturally, because no engineer is going to prefer for this infinite slope nowadays. Infinite we will call man-made slopes, or what exactly definition is. Infinite slope means it has a large distance comparatively width is compared to the width or span of the slope is large, hence it is infinite slope, and these are the natural slopes. Whereas finite slope distance is small. Distance is small, this we will call it as a finite and infinite slope. These are the types of the slopes actually. So you can write it as man-made slopes and natural slopes, and finite and infinite. You can find the description in any textbook, you can go through that one. So we'll move to the how slope is going to fail. So we have the types here, slope failure types. First one is transitional, slide or failed. How the slope is going to fail transitionally? So here failure of a slope along a weak zone of the soil. So what happens in the transitional slope means, so if this is what your slope, so this we will call it as toe, and this part we will call it as crest. Okay, and this is the base, and this is what the inclined portion is, what the slope, and here you have total soil. And here, so say here we, while constructing the structure, if this is the soft soil, say this span is soft soil, what happens when you apply some load, or because all these forces, because of these forces your slope is going to fail. So how fails means, when your, see this is what the soft, so obviously soft soil is going to fail. This is what your failure envelope or failure plane. Your soil is going to fail in this direction. So say here you have stiff soil, and this is what your hard soil, and where the soil is failing, where the slope is failing, along this line, this is what your soft soil. So when you have here, I have mentioned that failure of a slope along a weak zone of the soil. Weak zone is nothing but the soft soil. Weak zone of the soil is what the transitional slide. So sliding mass travels long distance before coming to rest. See here. So when it will come rest, when this total sliding wedge travel to this distance, then only this tray is going to rest. So this what exactly it is, sliding wedge will travel long distance before it will rest again. And common in case of the coarse grain soil, it is common in case of the coarse grain soil. So we'll go for the next failure, that is rotational slide. So why we will call it as a rotational slide means, here it is because it has a common point which is parallel to the slope, you can see here. So and if you see, I can draw this circle, whatever the slope failure curve, you can draw with this point. So that is when you rotate with an radius, you can draw clearly rotational slide. So this is the rotational slide. So it is common in homogeneous fine grained soil. It has a point of rotation, as I have mentioned. It has a point of rotation on an imaginary axis parallel to the slope. So it has, this is an imaginary axis which is parallel to the slope. So it has a common point, so through which we can rotate this failure. So again after this, so here we have in rotational slide we have three types. One is base slide, toe slide, slope slide. Already I have shown parts of the slope. Once again I will show here. So this is what your toe portion, and this is the crest, and whatever this span, this inclined span is slope, and this is what your base. Okay, so definitely if your failure plane is starting from the base, that is the base failure, and if it is starting from the toe, that is the toe failure, you can see here. And another one is slope failure. If your failure envelope here, you can check failure envelope is starting from here, so it is failure. So this will be happening, occurs by an arc engaged with the whole slope. And next here this will be the toe failure. This occurs when, so in base, while construction in the base, if you have stiff soil as well as soft soil, here you can see stiff soil and here you have soft soil, whatever the joint you have, or so when you apply the load, so failure will cross through the base and it will enter into the crest. So this whole portion is going to fail. So in toe portion, same thing. Obviously these are the very delicate places where your soil is going to fail. So these things are very, toe failure is common compared to this and this, compared to this, that is base sliding, toe sliding and slope sliding are most common. So again we'll go for the this one, whatever your slope, it is very rare. Normally if there is any mixture or low quality control, in that case only you can find this slope failure. So this is the rotational slide. And again in rotational slide, so we also call it as a circular failure or non-circular failure. Circular failure you can check in rotation. Why we will call rotational flip means always it will be having one point and a radius. So circular and non-circular failure. This is how. Circular means it will be having radius. Non-circular means, so we have one point but both the time radius are not equal. Okay. So this is one type, rotational slide. Now flow slide. So flow slide, this will occur when internal and external conditions force a soil to behave as a viscous fluid. So internal, that whatever the soil you have, and external forces are these forces: gravity, seepage, earthquake, erosion. These forces both intensively force the soil to move viscously. That condition, that time soil will flow down. So that is the flow slide. And here no failure plane, what you can call it as no failure plane, is no defined failure plane. Okay, it will just if you see the fail, I'll just draw the surface. Say this is the slope surface, so you can soil may flow like this. Okay, so there is no defined failure plane, and also it has, you can call it as multiple failure planes, and it will not be defined one, it may changes as your soil viscosity changes, and it will happens in case of the completely dry soil and in case of the completely wet soil. So now last one is block or wedge soil. Soil mass is fails along the joints. When soil mass, so block soil means like this. Okay, this whole block is going to fall down. This we will call it as block or wedge slide. So this happens when total mass is, so it will not gradually fail, it will fail suddenly. Total whole mass is whole this mass will fail. Next falls, this will happen because of the gravity. What happens, the rock will detached from the parent body, that will be because of caused by gravity of the soil. So this is the introduction about the slope stability. So tomorrow we will see what are the what are the, so normally what how you are going to analyze the stability of slopes. Normally slope stability is made commonly by using limit equilibrium approach. I think you would have studied this limit equilibrium, sorry, approach. What exactly limit equilibrium approach is? So what we will assume here is, one main assumptions we will do is failure is not on, is on the verge of occurring along an assumed or known failure surface. What we will assume, that failure is on the verge of occurring along an assumed or known failure surface. That means whatever the failure plane you are saying that here the, if failure occurs, it will occur through this way, it will occur to this plane. So this assumption you are doing, actually we don't know where soil slope is going to fail, but what assumptions we are doing in case of the limit equilibrium approach is that we are defining this failure plane. So that is the limit equilibrium condition. And here also one thing you have to, here comes the factor of safety. Factor of safety. So the definition of the factor of safety is, it is the ratio of the available shear strength, available shear strength to the mobilized shearing resistance. Mobilized shearing resistance, that is the factor of safety. When the factor of safety, so depends on the factor of safety, you can say whether the, so whatever your slope is stable or not. So available shear strength and the mobilized shear resistance. Available shear strength is because of the forces acting on the soil, and mobilized shear resistance is in the soil. Whatever the forces acting to that, there must be some resistance. If that resistance and forces acting or stress developed because of the forces, that ratio we will call it as factor of safety. If both are equal, this will be 1. If this is more and this is small, again factor of safety is more, that means it is safe. Same thing if it is less and this is greater, then factor of safety will be in smaller and your slope is not stable. So when based on this factor of safety, every time you are going to say whether the slope is safe or not. Okay, again also slope stability also depends on shear strength of the soil, and what are the drainage. Shear strength of the soil plays an important role, as you have discussed here. Mobilize shear resistance, that is nothing but the shear strength. So before going for this determination of the slope stability, some process we have to do, that is first we have to determine the shear strength. So how you are going to determine the shear strength? Laboratory experiments you are going to conduct. So when you are doing shear strength experiment for the slope stability, whatever the sample you are taking, that sample should be undisturbed sample. If disturbed sample, whatever the results, for that we have to go for applying lots of higher factor of safety. So to avoid that, go for the undisturbed sample and conduct the shear strength. Again, it again depends that shear strength, how you are going to determine it, whether drained condition or undrained condition. Drained condition results are, or undrained condition results, that again depends on which type of slope, for what is the function of the slope. Is it for holding some hydraulic forces, or is it for the railways, highways? Again depends on that drained and undrained conditions you have to select. Again requirements, the analysis of stability also requires the estimation of the actuating forces like the gravity forces, seepage forces and earthquake forces. These things also you have to keep in mind while designing the slope. So these are the slope stability basic things. So tomorrow, by tomorrow we will get the original, like this is the basic, and you may get the most probably asked questions are these: causes of slope failure, and what are the types of the slope failure, and types of the slope. Most commonly asked question, if theory is asked this much, another theory question will be what, how the methods which you are going to use, that is Taylor, another term you have to know, that Taylor's number you have to study, and then Felonius friction circle, Felonius circle, all those things we will study by tomorrow. Live section, we will try to go for the live section, and timing, whenever you will be free, just inform me before half an hour. I'll just come to the time, and after 1:30 we can't go for, because whatever the data I have, for that I cannot conduct the online classes. In college we have Wi-Fi, so you can directly conduct the classes, which will be helpful. So please inform me. And for the syllabus, once again I am telling, CI's 2 syllabus. For A division is shear strength of, stress distribution and earth retaining structure and slope stability, or by tomorrow's class, up to tomorrow's class. And for the B division, half portion of the stress distribution, earth retaining structure and slope stability, by tomorrow's class. These 3 things you have to study, and must no queries, no question on the syllabus. Only if you have any doubts, anything that you can ask, feel free to ask any time. You can contact me personally, or you can call me, or you can send personal message. If you are not feeling comfortable to send in group, please send it personally also. I will be answering all the questions. Please try to solve examples of the earth retaining structures, and as well as that stress distribution. So stress distribution half portion is for the B division, and full stress distribution chapter is for the A division. Okay, I will once again text the syllabus in group. Thank you.